Today, we're going to pull back the curtain on the hidden rules that keep our financial system from, well, falling apart. We're talking about the super complex models banks use to manage risk and the incredibly strict rulebook they have to follow to keep those models in check.
And that's a question that has some pretty huge consequences. Because you got to remember, these aren't just numbers on a screen. These models are the engines that decide how much risk a bank can take on. And if that engine sputters, or worse, completely fails, the damage can be massive.
Yep, that's the bottom line, a financial crisis. After the last big one, regulators realized they couldn't let it happen again. So they created a whole new, much tougher rulebook. So let's dive in and see what's actually in this thing, starting with the absolute bedrock of model safety.
And that foundation? It's called Model Risk Management, or MRM for short. The best way to think about it is like a master blueprint. Every single model a bank builds has to follow this blueprint, just to make sure it's safe and sound right from the very beginning. And this quote here from the German regulator really nails why this is so important. It points out that the crisis wasn't just one bad decision. No, it was a whole chain of failures, a systemic problem. And that's exactly why this kind of standardized, rigorous blueprint became non-negotiable. So what exactly is MRM? Well, it's basically the whole system, all the rules, the processes, the controls, and it's all designed to fight one specific danger, the risk that your model is just plain wrong, which leads to terrible business decisions and, of course, losing a ton of money.
Now, if there's one rule you remember from this whole thing, make it this one: independence. It is the absolute core principle. The regulators are super clear about this. The team that builds the model, the developers, has to be totally 100% separate from the team that checks their work, the validators. You just can't have the builders marking their own homework. It's the only way to have a system you can actually trust.
Okay, so think about it. If you're a big bank, you have hundreds, maybe even thousands of models. How do you possibly keep track of them all? You start with a catalog. Every bank is required to have what's called a model inventory. It's a master list of every single model they use, from credit risk models that predict defaults to market risk models that calculate something called value at risk. Everything has to be on this list. If it's not in the inventory as far as a regulator is concerned, it doesn't count. Okay, so you've got the blueprint and you've got the catalog, but that's just the start. You need constant inspections, because a model that's built correctly still needs to be checked all the time. So how do banks make sure these complex engines are actually running the way they're supposed to?
Well, rule number one is a regular health check. Regulations say that every important model, every material model, has to go through a full deep dive validation at least once a year. And this isn't some simple check-the-box thing. It's a serious inspection to find any problems and to see if any little tweaks made during the year have added up to a big change that needs reapproval. And one of the most important tools for that inspection, it's something called backtesting. This is really where the rubber meets the road. You take what the model predicted would happen in the past and you compare it to what actually happened. It's the ultimate reality check. It basically asks the model, so, did you get it right? And this little table here, it's a perfect example of how this works in practice. So you have a VAR model predicting the maximum loss for the day. Day 1, day 2, looks good. The actual loss was less than the model predicted. But then look at day 3. The model predicted a max loss of 900,000 euros, but the actual loss was 1.5 million. That is a fail. It's called an overshooting. And for a validator, that's a huge red flag. And these failures, they have very real consequences. The regulators use this simple traffic light system. A couple of fails a year, you're in the green zone, no problem. But start hitting the yellow zone with 5 to 9 fails, and you're getting some serious questions. And if you get to the red zone, 10 or more fails, the model is basically considered broken. And that's when the bank gets hit with a capital penalty, which means they have to hold more cash in reserve. And that directly hurts their bottom line.
All right, so backtesting looks at the past. But what about the future? The biggest risks are always the ones you don't see coming. And that's where we get to the really intense part. Stress testing. This is where banks are forced to simulate a complete financial nightmare, not to predict it, but to see if they're strong enough to survive it.
Yeah, the whole point of a stress test is not to be a crystal ball. It's about testing resilience. Regulators like the European Banking Authority come up with these extreme but plausible disaster scenarios, and they force banks to run them through their models to answer one simple but brutal question. If this happens, do you survive?
So in these big stress tests, you usually have 2 scenarios. The baseline is kind of business as usual. The economy is chugging along nicely. But it's the adverse scenario that everyone cares about. That's the one that simulates a deep, painful recession.
We're talking unemployment skyrocketing, GDP collapsing, property prices crashing. This is that financial Armageddon we were talking about.
And this is what happens. That adverse scenario hits a bank's capital, its financial safety cushion, like a sledgehammer. You can see how the capital level just plummets. The whole point of the exercise is to see if, even after taking that massive hit, the bank still has enough capital left over to stay in business.
But here's a really interesting detail that a lot of people miss. The way you run the simulation is just as important as the simulation itself. In fact, there's one single assumption that can completely change how bad the results look.
And it all comes down to the balance sheet. Regulators often force banks to use a static balance sheet. This is the toughest test. It basically assumes the bank is a sitting duck, that management can't do anything to react to the crisis. The other way is a dynamic balance sheet, which lets management steer the ship, sell off bad assets, change their strategy. You can probably guess which one shows a bigger hit to capital. The static one, by far. And that's why regulators love it. It tests pure, raw resilience.
So, after all that, what's the big takeaway here? It's that the whole philosophy has changed. It's not about having the smartest, most complex model anymore. What really matters now is having a process that proves your models are safe, that they're transparent, and most importantly, that they are resilient when everything goes wrong.
And that brings us to the big question for the future. This entire rulebook we've talked about was built to prevent the last crisis using historical data. But what about brand new risks, like climate change, where we have almost no historical data? How do you backtest for something that's never happened before? How does this whole rulebook have to change to handle a crisis that we can't even imagine yet? That is the billion-dollar question that everyone in banking is trying to answer right now.